All right, Venn diagrams are a fantastic way to look at probabilities. And you can see in here the general addition rule as well. So in this example for a Venn diagram, it consists of one or more circles inside of a rectangle. Each circle represents an event. So let's say event A is being male, and event B is having your ear pierced. Okay. So everything inside of the yellow circle is males. Everything inside the blue circle is ear piercing. Okay. This entire rectangle for the Venn diagram has to represent the entire sample space. So this whole rectangle has to equal every single individual in this table. So everything in here must be represented in this table. So I know the total inside this Venn diagram has to be 178. The total number of males is 90. What happens at first, a common mistake is a lot of students will put a 90 right here because it's males. No, the entire yellow circle must be 90. Okay. So everything inside the rectangle represents the whole world that we're dealing with in this problem. The entire sample space is contained within the rectangle. All right, let me clean this up a little bit so we can look at this again. Remember, event A is male and event B is your ear is pierced. All right, so we're going to talk about the intersection and union of events here. So when we build a Venn diagram and we want to put the numbers into the Venn diagram, we always want to start with the intersection. This intersection area right here, this green area, is the and. So how many students are males and have their ear pierced? Oh, male and, yes, your ear's pierced, and you're a male. Oh, that's 19. So 19 is the intersection, the and. How many students or how many individuals have both of the qualities that we're looking at? From a Venn diagram, we start in the center and we build out. So if I know that there is a total of 90 males, well, I already have 19 in the male circle right here. This is already 19. So this total yellow circle has to equal 90. So out here in the yellow area would be males and not ears pierced. And I can continue the process for ear pierced. There's a total of 103 students with their ears pierced. I already have 19 students with their ear pierced in this blue circle. So how many more do I need to get to the 103? Oh, I need 84. So this tells me that there are 84 people with their ears pierced who are not males. Yeah, 84 females with their ear pierced. Now this total has to always make sure to add up to the table total of 178. Well, right now it only adds up to 174. Therefore, there must be 4 individuals out here. All right, so what are each one of these individuals or each one of these sections? In a Venn diagram such as this, there will be 4 separate areas. Okay, so this 19 where we're going to start here is male and pierced. The 71 here is male and not pierced. The 84 is not male and pierced. And this 4 out here is not male and not pierced. The Venn diagram, I think, makes this much easier to do. Anytime we have 2 things happening simultaneously, the Venn diagram is probably our best bet to model the probability situation. You're going to really enjoy these Venn diagrams. It's going to make your life so much easier. By the end of the probability unit, you're going to be asking, I hope this is a Venn diagram type of problem. Anytime there are 2 events that happen simultaneously at the same time, then a Venn diagram is a good way to model that probability question. Okay. Now, we just talked a lot about this, but the events A and B, the intersection of the two events. Intersection means and. So this would be a picture of and, this green highlighted one in diagram B. The intersection, remember again, intersection, another way to say intersection in probability is and. And the symbol we use is the upside down U. This gives us a good visual representation of what the intersection is. It's the overlapping part of the two Venn diagrams, or the two events. Now we're going to talk about the union. We've already spoke about this word union. It's or. Intersection tells us multiply, and. Union tells us or add. The union is just a U. Union was A or B, so it's everything inside of A or B. So it's everything that's colored green. The Venn diagram on the left is the complement of A. Remember, this little C means complement, and we read it as not A. So if A is this circle in the center here, everything that's not A would be outside. This also happens quite frequently like this. If I have event A and event B, this is A and this is B. If I wanted to look at the complement of A here, it would be everything that's not inside of A. So it would be everything out here as well as this part of B that's not also inside of A. So the complement of A is everything except what's in the circle A. Okay. Venn diagrams, you're going to really grow to appreciate these. Anytime we have two things happening simultaneously, we'll want to model that problem with a Venn diagram, and it will make our job so much easier. All right, let's eat, man.